Now here's a representation of the histogram for 3 coin flips as constructed in class on day 3. The standard deviation of the results of 3 coin flips, if we count each possible result once, we calculate the standard deviation of the number of heads. Standard deviation is 0.87. Now the graph as I've drawn it, the histogram is represented by these rectangles. The graph as I've drawn it does a reasonable job, not a great job, of getting an area between the area of this rectangle here, for example, is equal to the area of under the curve between here and here. So if we take, well, here's an example. If we take this rectangle here, this rectangle, the area under the curve is kind of indicated in green, and that area should be equal to the area of that rectangle. Okay. So the area of each rectangle should be equal to the area under the curve between the left and right side of the rectangle. Okay. Now, having done that, you were asked to construct 2 lines, one a 1 standard deviation on this side of the mean, one at 1 standard deviation on this side of the mean. Now, here's an example of 2 lines, but these 2 lines are more than 1 standard deviation above or below the mean. We can see that the numbers here, here's 1 and here's 2. So here's 1.5, that's where the mean is, 1.5, halfway between 1 and 2. Between 2 and 3 is another unit. And I've constructed this line kind of down through the middle of this last bar of the bar graph or histogram, okay? And that line is clearly more than 1 unit. Each of these rectangles is 1 unit wide, so here's 1 unit from the mean. The mean's right here in the middle, obviously. And if we calculate, as we calculated the mean before, we know the mean is 1.5. So this is about 1.5 standard deviations. Okay, we want 2 lines at 0.87 standard deviations. So you should sketch your own curve and see if you can do that. And you should pause and do that before you hear any more. Okay, so you've been asked to sketch the region within 1 standard deviation of the mean. We want a line 1 standard deviation above the mean, a line 1 standard deviation below the mean. Standard deviation is 0.87, that's less than 1. Okay, so from here to here is a standard is 1, and the standard deviation is 0.87, which is about 7/8 of 1. So that's going to put it here, pretty close to pretty close to 1 unit from the mean, but a little bit less. So here's the standard deviation on this side of the mean, and then everything is nice and symmetric. Here's a standard deviation on the other side of the mean. And then what I ask for is the area of the region between 1 standard deviation below and 1 standard deviation above the mean as a percent of the total area under the bell-shaped curve. So what's the area under the bell-shaped curve between here and here as a percent of the total area? Now I gave a couple of hints. I asked, do you think it's more than half of the area or less? And everybody pretty much said, well, it's clearly more than half the area. So your estimate would be more than 50%. Then I looked at these tails over here, the tail of the distribution beyond 1 standard deviation. I said, well, is that more or less than 25%? And everybody pretty much said less than 25%. And that's a good thing, because if this is 25% and this is 25%, that leaves only 50% in here, and you already decided that this was more than 50%. So using a little bit of common sense with that hint, what do you think the percent of the area under the bell-shaped curve is between the 2 lines? The percent of the area between the 2 lines as the area between the 2 lines as a percent of the area of the whole thing. And people came up with different estimates. Okay? Okay, yeah, so you should have your estimate. And I'm going to tell you. The estimate, if you estimated 2/3 of the area is in here, you would be pretty close. Now there's an actual percent, and it's just a little more than 2/3. Not 2/3 of a percent, but 2/3 expressed as a percent would be 0.66 and 66666%. And the actual is closer to 68%, but that's pretty close. Okay, so I want you to see that. Now we're going to build on that. We're going to do some things with it, but that's a kind of an important picture. Matter of fact, it's an extraordinarily important picture. It basically underlies the whole study of statistics, which is very important in most fields.